In this question, we just want to know how many perfect cubes are there that lie between 2 to the power of 8 plus 1 and 2 to the power of 18 plus 1. So basically, how you would do this problem is you want to find how many perfect cubes there are from 2 to the 8 plus 1 all the way to 2 to the 18 plus 1. So the idea is we first look at the upper and lower limits, right? Let's look at the lower bound, 2 to the 8 plus 1. Well, 2 to the 8 plus 1 is a pretty small number. Like you can calculate this by hand. So it's a good idea for like math competitions to like memorize your powers of 2. Like it's usually a good idea to like memorize your powers of 2 so you don't have to like say, oh, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32. Like, because that would just waste time. Like I would recommend maybe you can like memorize your powers of 2 up to like 12 or 13, maybe 14 or 15. But like 2 to the 8 is 256. If you didn't memorize that, you can easily calculate it. So 2 to the 8 plus 1 is going to equal 257. But 2 to the 18 is a little more tricky because 2 to the 18 plus 1 is a really large number. Like it's kind of hard to work with. Like you can't really like calculate it out. Like it would be if you did calculate it out, it would be a really large number and it wouldn't be very cool. So what we would do is we first focus on 257, right? What's the smallest perfect cube that lies above 257? Well, like we know that like if you were to list out perfect cubes, 5 cubed is like 125, 6 cubed is 216, 7 cubed is 343. So we see that 6 cubed 216 is less than 257, but 7 cubed is 343, which is greater than 257. So the smallest perfect cube that is bigger than 257 is 7 cubed. And now let's look at 2 to the 18 plus 1. Notice that we can write 2 to the 18 plus 1 as like, notice this plus 1 is kind of like irrelevant, right? Or not irrelevant, but like when you're dealing with such large numbers, the plus 1 is kind of like insignificant. So let's first focus on the 2 to the 18. Notice that we can write 2 to the 18 as 2 to the 6 cubed, and then we have the plus 1. And the reason this is helpful, and the reason this is true is because, using your exponent rules, like a to the b to the power of c is equal to a to the power of b times c. So the reason this is helpful is because 2 to the 6 is easy to calculate. It's just 64. So this equals 64 cubed plus 1. And the reason this is helpful is because 64 cubed is clearly less than 64 cubed plus 1. And 64 cubed plus 1, we just like did some algebra and we knew this is equal to 2 to the 18 plus 1. So the largest perfect cube less than 2 to the 18 plus 1 is 64 cubed. So that means all the perfect cubes from 7 cubed all the way up to 64 cubed are in this range from 2 to the 8 plus 1 to 2 to the 18 plus 1. So we just basically want to count how many numbers are there from 7 to 64. So from 7 to 64, there are just going to be 64 minus 7 plus 1 equals 58 numbers. And that would be choice E, and we would be done.